Okay, so again, here's our little chart that we went through in the previous lesson as far as what happens if you multiply the dimensions of a figure by a. The perimeter is multiplied by a also. The area, since area is two-dimensional, length times width, you get that number squared is multiplied by your area, your original area. And if it's volume, since it's three-dimensional, it's that number to the third power. So we talked about what would happen if you had a figure and you multiplied it, all of its dimensions. It does have to be all of its dimensions by 4. The perimeter would be multiplied by 4. The area would be multiplied by 4 times 4, or 16. And the volume would be multiplied by 4 times 4 times 4, or 64. Even if it's a fractional change, 1/4, what would happen to the perimeter if you took all the dimensions in the figure times a fourth? Well, the perimeter would be times a fourth. The area, on the other hand, since it's two dimensions, it's changed by a fourth and a fourth again. 1/4 times 1/4 is 1/16. And the volume is multiplied by, it's three-dimensional, so you're doing times a fourth times a fourth times a fourth 3 times. And that is 1/64. Okay, so here's an example. It says the length, width, and height, all of the dimensions are tripled. So that means they're multiplied by 3. Describe the effect on the volume. Well, I can do this pretty fast using my properties I talked about up here. If all the dimensions are multiplied by 3, what happens to the volume? It's multiplied by 3 to the third power, or 27. Okay, it's 27 times the volume of the original. Okay, the other way you could do that is to just find the volume. The volume of this figure originally is length times width times height, 5 times 8 times 2, or 80. And if we were to go through and triple the dimensions, then this would be 15, 8 times 3 would be 24, and 2 times 3 would be 6. And your new volume would be 15 times 24 times 6. Which gives me a volume of 2,160. And then to find out what the effect is, if you're doing it this way, you take the you take the new one divided by the old one. Okay, so the new one had a volume of 2,160, the old one had a volume of 80. You divide that, 2,160 divided by 80 is, ta-da, 27. Okay, which we predicted here. Let's talk about, however, what happens if the length and the height of a prism are tripled. Notice not the width, only 2 of the dimensions were changed. Describe the effect on the volume. Now again, the original volume, before we made any changes, what was the original volume? Erase those. The original volume we had right here was 80, 5 times 8 times 2. What happens if we triple the height and the length? So we triple the height here, 2 times 3 gives me a new height of 6, and we triple the length. 3 times 5 gives me a new length of 15. What would the volume be now? Well, the volume would be length of 15 times width of 8 still, because we didn't change the width, times the height of 6. That gives me 720 for my new volume if I'm tripling the height and the length. Again, to find the effect, you take the new and you divide it by the old, and that will tell you how many times larger it is, okay, or smaller. So we have our new of 720 divided by the original volume of 80. When we do the division, we get 9. So what's the effect? It's 9 times larger. Now notice what happened here. We tripled it or multiplied by 3, but we only changed 2 of the dimensions. Okay, so the change we got was 3 to the second power, or 9, instead of 3 to the third power. Here we changed 1, 2, 3 dimensions, so when we tripled it, we had it to the third. You can work it out either way. Okay, let's do an example here. What is the effect on the volume of multiplying the right triangle's dimension, or right rectangle's dimensions by 1/3? Okay, so what would the effect be on the volume? Well, let's find the original volume. Okay, so our old volume. Again, a rectangular prism, the volume is length times width times height. In this case, 9 times 1 times 6. Gives us a volume of 54 cubic feet. Okay, now notice we are changing all the dimensions. I'm going to make my prediction. If we're multiplying by 1/3, the volume should change by that number cubed, which would be 1 over, because 1 to the third is 1, 3 to the third, or 27. Okay, so it's going to be 1/27 of the size. That's my prediction. Let's go ahead and find out what is the new volume going to be. Okay, we need to multiply all these by 1/3, which divides them by 3. So 6 divided by 3 would drop this to 2 feet. 1/3, or 1 times 1/3 would drop this to just 1/3. And 9 times 1/3 would divide that by 3, so it would be 3. So my new dimensions are 3, 2, and 1/3. So the new volume would be 3 times 1/3 times 2. 3 times 1/3 is 1, times 2 is just 2. Okay, so remember to find the effect that we had. We take the new and divide it by the old one and then simplify. The new volume is 2. The old volume was 54. If I reduce that fraction, what do I get? 2 goes into 2 once on top. 2 goes into 54 27 times. It's 1/27 the original size, which is what our prediction was up here. But again, that's because we changed all of the rectangle's dimensions. Okay, suppose the length and height of this right rectangular prism are multiplied by 1/3. Now notice this time it's just the length and the height. What is the effect on the volume? I'm going to make my prediction. My prediction is it's multiplied by 1/3, but it's only 2 of the dimensions. So it's only going to be squared instead of cubed. Okay. 1/3 squared, 1 times 1 is 1 for the top, and 3 times 3 on the bottom is 1/9. I'm predicting it will be 1/9 the size, but let's try it out. Now our volume, remember for our old volume before we make any changes, is going to be 9 times 1 times 6, length times width times height, we did that on the previous one, was 54. Now let's find for the new one. We want the length and height to be multiplied by 1/3. Okay, so the length is 9. If we multiply that by 1/3, we get 3. Okay, and the height, 6. If we multiply that by 1/3, or divide by 3 is really what you're doing, we get 2. Okay, so what would the new volume be if these are our new dimensions? Okay, our new volume would be length of 3 times width of 1 times height of 2. 3 times 1 times 2 is 6. To find the effect, we take the new, divide it by the old. The new one was 6, and the old one was 54. If we can reduce the fraction, we want to reduce it. If you divide, you're going to get a decimal. 6 divided by 54 is 0.1111. So let's just reduce the fraction. Well, 6 goes into 6 one time. 6 goes into 54 9 times. So the reduced fraction is 1/9. So what's the effect? It's 1/9 the original size, which is what I predicted using just our observations that we talked about.